Multiplication of monomials in different variables is handled the same way as if it was all in one single variable. Here we have a monomial times a monomial, but first we have this monomial raised to a power. Following the order of operations, we need to take this monomial raised to that power first, since exponents have the priority over multiplication. So we'll ignore temporarily the negative 2x. Here we have a product raised to a power, which means each one of those factors is raised to the third power. Simplifying further then, negative 3 to the third power, negative 3 times negative 3 times negative 3 results in a negative 27. Our x to the third is already taken care of. But here we have a power raised to a power. We'll multiply those exponents for a simplified y to the sixth. We're now left with multiplication and rearranging to put our like terms together. We have our constant terms, our variables that are similar to one another that we can simplify. Rearranging these terms so that we have similar terms multiplied next to one another is the commutative property for multiplication that allows this for an equivalent expression. Simplifying, we end up with a negative times a negative is positive. 27 times 2 is 54. Common bases multiplied together with this x understood to have an exponent of 1 results in common bases multiplied together, add exponents, and we still have our multiplication by the y to the sixth power. So that's the result of those two monomials multiplied together. Here we have a monomial times a binomial. We will use the distributive property, multiplying each term of that polynomial by AB. So we have AB times the first term plus AB times the second term minus AB times that third term. Using commutative property to simplify and recognizing this is a to the first, we have our 3, a to the first times a to the second, common bases, add your exponents, a to the third b. When we use commutative property to rearrange and simplify, here in our multiplication, we'll bring the constant term to the front. We have an a times a, which is a to the power of 2, and a b times b when we use our commutative property for b to the second power. A negative times a positive is negative. We'll bring the 7 to the front. There is only the a, but when we use our commutative property and rearrange, we have b to the first times b to the second, resulting in b to the third power. When you can do these mentally, it'll definitely speed up the steps, but just to show you the distributive, we did show each step as we went along.